Hello students, in this lecture now we are going to do the remaining 3 numericals of back exercise of chapter 8 motion and will hopefully complete the chapter with this lecture. Now let us do the 7th numerical. A ball is gently dropped from a height of 20 meters if its velocity increases uniformly at the rate of 10 meter per second square. With what velocity will it strike the ground? After what time will it strike the ground? I'll read the question once again and then now you should write what is given side by side. A ball is gently dropped. So given u is 0 meter per second. Remember, whenever a body is dropped from certain height, we will write u is 0 meter per second. Or whenever an object starts from rest or starts from stationary position, u has to be taken as 0 meter per second. A ball is gently dropped from a height of 20 meters. So obviously this ball is going to cover the distance or height 20 meter. We'll represent this by s. S is 20 meters. If its velocity increases uniformly, velocity increases uniformly means it is a case of uniformly accelerated motion. At the rate of 10 meter per second square. So 10 meter per second square is acceleration. We know that the ball is falling down and this acceleration is also in the downward direction because remember, for a freely falling body, acceleration is always in the downward direction. So as direction of motion and acceleration are in the same direction, this should be taken as positive only. With what velocity will it strike the ground? We have to find v, final velocity when it strikes the ground. And after what time will it strike the ground? Time t. We have to find. So we have written what is given and what we have to find out. No conversion is required here. The units are proper in the same system of units. So let us proceed. First, to find v, we can use the third equation of motion. V square is u square plus 2as. Putting the value of u from above, 0 square plus 2 into a is 10, s is 20. Putting these values and just simplifying this, we get v square is 400. So v is square root of this 400 you have to take and the answer is 20 meters per second. So you have got the answer. The ball will strike the ground with velocity 20 meter per second. After what time? So second part you have to find the time and we can use the first equation of motion for that. V is u plus 80. V you have found just now 20 meter per second is equal to u is 0 plus a is 10 into t. So 20 is 0 plus 10t, that is 10t, and t will be equal to 20 divided by 10, that is 2 seconds. So the ball will strike the ground after 2 seconds with velocity 20 meter per second. Hope you have understood this. It was quite a simple numerical. Now 8th we have done in our previous video, that was based on graph. 9th question, I'll read it now. State which of the following situations are possible and give an example for each of these. A part, a body with a constant acceleration but with 0 velocity, and B part, an object moving in a certain direction with an acceleration in the perpendicular direction. I'll repeat the question. State which of the following situations are possible. If they are possible, you have to write yes. If not possible, no. And when you write yes or no, when you write yes, you have to give an example for each of these. So here I have just done first the A part. You have to write an example if it is yes for a body with a constant acceleration but with 0 velocity. Think over this. Can a body have 0 velocity and constant acceleration? Yes, it is possible. In the previous numerical itself, we have seen that when the ball is released, at the point when it is released, its velocity is 0 meter per second. And as it is a case of freely falling body, uniformly accelerated motion, so acceleration is uniform. So this is also one example, and similarly we can write when a ball is thrown in the vertically upward direction. When a ball is thrown in the vertically upward direction, what happens? Velocity decreases first, and at the peak position velocity becomes 0 and then it falls down. For the entire motion, in that case also, it is considered to be a case of uniformly accelerated motion with acceleration approximately 10 meter per second square in the downward direction. So I have written here the answer. Yes, it is possible. A body with constant acceleration but with zero velocity is possible. How? Examples I have written. When a body is thrown vertically upwards, at the peak position, its velocity is 0 meter per second and acceleration is approximately 10 meter per second square, which is uniform. Or when a body is gently just dropped or released from some height, then its velocity is 0 meter per second at that point and acceleration is uniform, which is approximately 10 meter per second square at that point. Uniform remains same throughout the motion, but we are talking about at the point when it is released or at the peak position, velocity is 0 meter per second and acceleration is also uniform. Hope it is clear to you. Now, the B part of ninth numerical is state whether this is possible. If it is possible, we have to give an example. An object moving in a certain direction with an acceleration in the perpendicular direction. Is it possible? Yes or no? Yes, it is possible. How? I will explain you. See, remember students, the case of uniform circular motion. When a body is in uniform circular motion, let us say this is a circular path and the body is moving in the anti-clockwise direction, this way. So at any point, we have done it before also, that at any point the direction of motion, that is the direction of displacement and so the direction of velocity at any point is what? Along the tangent to the circular path at that point. What is tangent? A line which touches a circle externally at only one point. So this is the direction of displacement, and we have also done this before. We have done it that at this point the acceleration which is there is called as centripetal acceleration and it acts along the radius towards the center at that point. So it means what? That at any point on the circular path, direction of motion is along the tangent and acceleration of the body is along the radius towards the center. And we should know that this tangent and acceleration are perpendicular to each other. They are perpendicular to each other. So I can put this sign here to show that it is rectangle. They are perpendicular. Okay. So we say it is possible. When a body is in uniform circular motion, at any point on its path, its direction of motion is along the tangent to the circular path at that point, as I have shown here, and centripetal acceleration is along the radius towards the center at that point. And as tangent and radius at any point on the circle are perpendicular to each other, it means this tangent and radius are perpendicular. So anywhere you draw the direction of displacement and acceleration, they will be perpendicular. Therefore, direction of motion and acceleration of body are perpendicular to each other. I hope you have understood this well. Now let us proceed to the last numerical of this chapter. An artificial satellite is moving in a circular orbit of radius 42,250 kilometers. Calculate its speed if it takes 24 hours to revolve around the Earth. I'll read it once again. An artificial satellite is moving in a circular orbit of radius 42,250 kilometers. So given radius, which I have represented by small r, is 42,250 kilometers. Calculate its speed. Speed we have to find out. If it takes 24 hours to revolve around the Earth, Time is 24 hours. Now students, remember here, although they have not mentioned, but we should know that it is a case of uniform circular motion. And hence they have asked us to find out the speed. So we shall assume that speed is constant of the satellite. Now we know the formula for speed is distance upon time. This time is what? This time is taken by artificial satellite to revolve once around the earth. Okay, so S should be the distance covered when it revolves around the earth, when it completes one round around the earth. What is the distance travelled? If the path is circular, that is equal to the circumference of the circle. So that is 2 pi r. So distance travelled is circumference of the circular orbit 2 pi r divided by t. Now that is in kilometer and this is in hours, so no problem. We can get the answer in kilometer per hours. So 2 into pi is 22/7 into r is 42,250 kilometer divided by 24. And when we simplify it, we get the answer 11,065.476 kilometer per hour. We can round it off to 2 decimal places as shown here, because last digit 6 is more than 5. So I can increase the second last 7 by 1. So it will become, instead of 0.47, I'll write 0.48. So 11,065.48 kilometer per hour. Or I can write the answer in scientific notation as I've explained you before. First number has to be more than 1 and less than 10. So I've written 1.11 after rounding it off to 2 decimal places into, as I have shifted the point to 4 places on the left hand side, so it will be into 10 raised to 4 kilometer per hour. I hope you have understood these numericals well. Yes students, in the previous lecture we have seen how to find the area under VT graph, which gives us a distance travelled during any time interval. Okay, I have drawn, I know I have explained you earlier, but I know that it's not very easy for you to understand. So I have tried my best to make you understand this by drawing this. Here the answer may be different than the answer which we have got previously, because the curve may be a bit different. But still the important thing is you should understand it. Now this is VT graph. V is in meter per second, T is in seconds. Here after 5 divisions we have 2. So scale on x-axis, 5 divisions is 2 seconds. So one division, value of one division is 2/5 seconds on x-axis. On y-axis, 3 divisions is 2 meter per second. So one division is 2/3 meter per second. Now one method to find out the area under this graph. See, this is straight line which I have drawn afterwards. The graph is this curved line and then it goes straight. Okay, so we have to find out distance travelled in first 4 seconds. Please don't look at this straight line now. This is a construction which I have done for the second method. Now for this, what you will do, you will find the number of boxes under this graph in this area. Okay, so number of boxes, how will you calculate? Like here, from 4 towards this side. How many boxes are there? 9.5. In the second line, if you count, number of boxes are 8.5. In the third line, it is 7.5 and so on. In this way, I have counted the number of boxes in each line in this area under this curved line. So that gives me the number of boxes in this time period 0 to 4 seconds below the graph. And when I take the total, number of boxes come out to be 46.5. Now we know distance travelled will be area under the graph, that is area of all these boxes. What will be area of all these boxes? Area of one box into 46.5 number of boxes. And if I see area of one box will be, just see the scale, length is 2/5 seconds and breadth I can take 2/3 meter per second. So length into breadth will be area of one box into 46.5 and the answer here comes out to be 12.4 meters. So in this case, I have drawn the curve here. This is a curve. This is a graph, curved one. Okay. So we can say that distance traveled in first 4 seconds is 12.4 meters. I hope this method is clear to you. Now we'll continue with the next method. So second method is, students, here. Now in this case, I have drawn one straight line. See the straight line. Okay. So this straight line has divided this area under the graph into two parts. One is triangular shape and the other is this part left. So what we can do is, instead of counting so many squares, which is time consuming, I'll find the area of this triangular region by using the formula half into base into height. So half into base is 4 and height is this much, from 0 to this. Now this is 4 plus 2 divisions, and 4 plus 2 divisions. What is the value of 2 division? 1 division is 2 by 3 meter per second. So 2 divisions will be 2 into 2 by 3, that is 4 by 3 meters per second. So you can find out area of triangle as half into 4 into height is 4 plus 4 by 3, that is 16 by 3. And when we get the area of triangle, we get 32 by 3 meters. So we can find the number of boxes in this region between the two lines. We can find out the number of boxes and area of 8 boxes as we have done there. So if suppose whatever boxes are there, you can find the area. You can count the number of boxes and find the area by using that formula of area of one box. And then you can add this area of triangular region plus number of boxes, area of those number of boxes, you will get the distance covered or area under the graph, which represents the distance covered in first 4 seconds. Students, I have just explained you how to do this. Here I might have approximately counted the number of boxes as my graph is not perfect here. But when it is drawn on your graph paper, it will be accurately done. Okay. So hope the chapter is clear to you. And please revise this chapter properly to make the concepts clear, as this chapter is a base for the next coming chapters. Okay. So all the best, students. Hope it is clear. Revise the chapters and like the videos if you have understood the chapter. Thank you, students.